Hello. Hello.
Good morning, ma'am.
Good morning, ma'am.
Good morning. Whatever question I gave you in the last class, I hope you all solved it. You all solved that question or not? Again, I am asking, You solved that question or previous class question or not? Please reply fast. We don't have much time.
Yes, ma'am.
Okay. You all solved that question? Akash Kachar, Amrita, Ankit, Aparna, Arjun Singh, Babli Kumari, Teji Rane,
No, ma'am.
Kailash.
No,
Why?
ma'am.
Why, Babu? Why?
Ma'am, it's a different type of question. So we are stuck in between.
Okay. If you need my help, then tell me, na. Why waste your time? Okay, then first I solved that question. The question is, again I repeat the question. The question 300 into 650 mm overall depth is provided. Means B into capital D is provided here. 300 into 650 mm. Right? For simply supported span of 6 meter of length 6 meter means L is given, length is given 6 meter, subjected to live load here I denote live load by WL is 20 kilonewton per meter, excluding self weight. Means self weight of the beam is not included in that load or weight. Then there is a two part. First is to find out stress developed in steel and concrete means C and T we have to find out in this question if and what is the criteria when if M is 11 and area of steel is given that area of steel is given which is 4 bars of 25 mm means 4 bars are used here of dia 25 mm means AST. How we find AST then? 4 dia, so 4 into area of 1 bar, 5 by 4 into 25 mm square. Right? In this case, we have to find out C, stress in steel, concrete, and T, stress in steel. When modular ratio is 11 and AST is
1963.4954 square.
1963.
49.
1 minute. Now tell me. 1963. 3.49 mm square, right?
Yes, ma'am. Yes, ma'am.
When modular ratio is 11 and area of steel is around 1964 mm square, right? And the second part of the question is, in the above case, M25 concrete and Fe500 steel are used. Means when M25 grade of concrete and Fe500 grade of steel we use, in that case we have to check whether section is safe or not and calculate the maximum moment carrying capacity of the beam. Second part, if M25 and Fe500 steel are used, in that case, we have to find out the section is safe or not, right? And the maximum moment carrying capacity of the beam. Basically, in that question, we have to find out moment. In first part, we have to find out stress in concrete and steel, that is C and T. And in second part, we have to find out moment. Then we start solving this question. This is your beam section where this dimension is 300 mm according to your question. This dimension is capital D, equivalent to 650 mm overall depth of the beam, and this distance or this length is L, equivalent to 6 meters, and this beam is subjected to, and according to this question, this beam is subjected to live load, means 20 kilonewton per meter, means load I draw here like that, and this load is 20 kilonewton per meter. Right? Live load always act like a UDL. This figure is clear or not? It is
Clear,
clear,
ma'am.
to all? In that case, load acting on section, means first step is load calculation. Load where we know which is live load 20 kilonewton sorry, 20 kilonewton per meter, but here the self weight of the beam or is not included here. Then we have to find out self weight is or I write and how the self weight or then how we find and self weight of the section or of the beam. You have any idea? Then tell me. How we calculate dead load? Again, I am asking how to calculate the self weight or dead load of the beam or dead load of the beam means WD. कुछ बोलोगे नहीं तो पता कैसे चलेगा?
मैम पहले उसका वॉल्यूम फाइंड करके फिर उसके आरसीसी के डेंसिटी से मल्टीप्लाई करने पे आ जाएगा लोड।
Yes, yes, yes. We know that density. We know that density is equivalent to mass by volume. तो इधर हमें density और write as a note actually in case of RCC density of concrete is 25 kilonewton per meter cube. And in case of pre-stress concrete, PSC, pre-stress concrete, density of concrete is 24 kilonewton per meter cube, right? Then we find out here WD is equivalent to volume into density, mass मतलब weight into density, sorry, weight is equivalent to volume into density, ठीक है? Then in that case, WD is equivalent to 300 mm into 650 mm into 1000 mm into 25, where 3 meter is your width of the beam, 0.65 is overall depth, 1 into 25 kilonewton per meter cube. After solving this, we get
4.875.
4.875.
4.875 kilonewton per meter. Then the total load becomes, W is equivalent to WL plus WD. Means WL live load, which is given here in the question 20 kilonewton per meter, and WD 4.875 means 24.875 is the total load of the beam. Kilonewton per meter. Now we know the total load acting on the beam. Then we find out the bending moment of this beam section, and tell me what is the formula of bending moment.
WL square by 8.
WL square by 8, where W is 24 into 875 kilonewton meter per meter, sorry, and L square is 6. 6 square divided by 8. Then tell me what we get after solving this. 111
0.937.
0.937, right? Kilonewton meter. Now we know due to the total load acting, due to the load 24.875 kilonewton Newton per meter is acting on the beam, and due to this load, the maximum bending moment generated in this beam section is 937 kilonewton meter. Right? Means our bending moment for safe condition, bending moment is equivalent to MR, or bending moment is less than MR. Right? For safe condition, bending moment either equivalent to MR, means moment of resistance of that section, and bending moment is less than the MR of that section. In both cases, our beam section is safe. When bending moment is equivalent to MR, then we can say that our section is balanced section. Right? Now, I draw a beam section here, and this is your neutral axis, and I also provide 4 bars here. Mm, and overall depth is given 650 here, and we take or assume D dash effective cover is 50 mm. Then write down, let's assume we provide D dash, means effective cover is equivalent to 50 mm, and from here to here we know that this distance is, what is this distance? From top fiber to neutral axis,
Actual depth of neutral axis.
N, right? And now I draw a stress section here, and at this point we have no idea our section is balanced section or under reinforced or over reinforced, right? So that I draw it like this. And in this case, we have to find out stress C and tension tensile stress T है. Now, moving to the first part, to find out the stress in concrete and stress in steel. For this, we know that D into N square divided by 2 is equivalent to M into AST into D minus X, N. Right?
Yes, ma'am.
In that case, we have the value of B here, M here, AST here, D here. Then put all the values. After putting all the values, we get the value of N here. Then you guys tell me, after solving this, what we get. What is the value of B? B is 300 mm, right? We don't know, still we don't know the neutral axis depth, N square. The value of M is given in the question 11. AST, the value of AST is 1964 into D. D is, how to find out D? Capital D minus small d dash minus N. Still we don't know the value of N here.
मैम 230.644 का क्या था?
After solving this, we get the value of N
230.644.
is equivalent to 230.644.
Yes, ma'am.
You all get the same answer?
Yes, ma'am.
Now, we have the value of neutral axis depth. Then we have to find out the stress. Now we have to find out the stresses in concrete and steel. For this, first you write down, stresses are always found by bending moment and moment of resistance. As I told you earlier, when bending moment is equivalent to MR and bending moment is less than MR, then our beam section is safe, right? Stresses are always found by bending moment and MR, so that still we don't have any idea our beam section is under reinforced, over reinforced, or in a balanced condition. We assume our beam section is in balanced condition. In that case, if we assume, okay, in that case, bending moment is equivalent to MR, right? And we know the value of bending moment is 111.937, right? Kilonewton meter. And we know the moment of resistance formula. What is the moment of resistance formula? Either in compression or in tension. What is the moment of resistance formula? Again, silence.
Ma'am, C into lever arm or T into lever arm?
पूरे क्लास में सिर्फ एक ही या दो स्टूडेंट हैं क्या? बाकी क्या सिर्फ सुनने आते हो? Sonu Kumar Gupta, what is the formula for moment of resistance? Sonu